Today we're going to start talking about physical versus chemical properties and physical and chemical changes. So a physical property. The definition of a physical property is a characteristic of matter that can be observed or measured without changing the material into something new. A physical property is a characteristic of matter that can be observed or measured without changing the material into something new. So some of those examples are, density, okay, how something sinks or floats. Density is, if you remember back from middle school, is mass divided by the volume. The temperature of something, the color, shape, size, the texture, how does it feel? Resonance, we really don't talk about resonance in here, so I'm just going to cross that out. Solubility, how does it dissolve? The ability for it to go into solvent. The boiling point, the melting point. Conductivity, that's the ability to conduct electricity. So electricity or heat. Malleability, what does malleability mean? So if something's malleable.
How easily it can move. For example, gold is very malleable, but yet, forget what it is.
You can make it into foil
Steel is not very
without
malleable.
changing its chemical composition.
Okay, so malleability is, the definition of malleability is to be hammered into sheets. Okay? Ductility, does anybody know what ductility means?
How it conducts electricity.
No, that's conductivity. If it's ductile, if it's ductile, what does that mean? We're not going to hammer it into sheets. Now in ductility, what we're going to do is we're going to take it and we're going to pull it into long strands. Okay, to be able to be pulled into wire. And then luster, what does luster mean?
Shine.
Okay, the ability for it to shine. So those are just characteristics of physical properties. Yes, Joel.
Would viscosity be physical?
Yes, viscosity. Like how thick it is, how it moves as a fluid. Is it really thick fluid or is it like really thin fluid? How?
For example, water is very fluid, therefore it has a kind of like...
Water's low viscosity while oil is a high viscosity. It's very thick. Doesn't flow. Okay, everybody good with this? No, you need a second? Let me pause this while you... So, we're going to take physical properties and we are going to further classify them as whether they are extensive or intensive. Intensive or extensive. So what you need to do is you need to make a T-chart. And we are going to have intensive versus extensive.
What was the second one we just read?
Shape. I just didn't like those.
I was just curious.
Okay, so intensive does not depend on the amount of matter. Okay, so I am going to use boiling point as my example. Okay, so intensive does not depend on the amount of matter, while extensive does depend on the amount that's there. So the boiling point in degrees Celsius, not Fahrenheit, of water is what?
Intensive.
No, tell me what the boiling point of water is.
Celsius 100.
In Celsius, it's 100 degrees Celsius. If I have a cup of water, it's going to boil at what temperature? 100 degrees Celsius. If I have a gallon bucket of water, it's going to boil at what degrees? 100. If I have a tub of water, it's going to boil at what degree? 100. So, do you see, as I increase how much is there, the boiling point of water is still 100 degrees Celsius. Now, it may take longer for it to get up to boiling point, but it's still going to boil at 100 degrees Celsius. So boiling point, we would say, is what? Intensive or extensive? Intensive. The melting point of said water is at that's Fahrenheit though. So at 0 degrees Celsius, water freezes. So, and then anything above that, it will start to melt. So whether it's an ice cube or if it is an iceberg, the melting point is still going to be the same. So it is intensive or extensive? Intensive. Conductivity, the ability for it to conduct electricity, does that matter on how much of it is there? No, so it is intensive. What about malleability? Hammer it into sheets. Is it going to matter how much is there? I think it might just take longer to shape it or something if there's more there, but it's still going to be malleable no matter how much is there. And what about ductility? If malleability is intensive, then ductility is going to be intensive too, the ability to pull it into strands. Might take longer to take a big piece of copper and pull it into strands, but it's still going to be easily pulled into strands. What about luster? Intensive or extensive? Intensive. Density. Okay, so I have a ruler, and the ruler is made of balsa wood, and balsa wood is really light. And so when I take say a meter stick and I throw it on top of water, it's going to float. Now if I take that meter stick and I break it in half, what's going to happen when I throw both halves on the water? They're still going to float. If I break it in half again and I throw it into water, what's going to happen? It's still going to float. So the density does not change. So it is intensive. And remember, I said density was mass divided by volume. So if I change the mass and the volume changes, so it's just a ratio, and that ratio is always going to be the same. What about temperature, the temperature of something? Does that depend on how much is there? No. Just takes longer to heat up. What about color? No. What about size?
Yeah.
Yes. What about texture? No. So something else I want to add on here? What about the mass of something? Does that depend on how much is there? Yes. What about the length of something? Yes. What about the volume of something?
Wait, if it's the length of something, then wouldn't ductility be intensive and extension now?
Ductility is intensive. It's just the ability to pull it into strands.
Oh.
Whereas length is the actual size that we pulled it into. All right, so you see that these are all measurements? Length, mass, volume, size. Those are all measurements. Measurements are extensive properties. Yes?
Oh, already.
Okay. Any questions on those? There's another thing that I've added here, and that is the amount of energy. So energy is also an extensive property. So the bigger it gets, the more energy it may have.
True.
And we already got the intensive properties over there. So these are things that we've already put in our T-chart. Okay. So,
periodic table shoes.
mm-hmm.
Are they
Pretty
really
clean.
Are they really weak?
Where'd you get on?
So if I wore those on the test, would that be considered cheating? Oh yeah. But that doesn't have their actual names. So if you don't know what the symbols stand for.
Dude, those
Sure,
guys
yeah.
have names.
Basically.
All right. A chemical property is observed when the substance is exposed to other substances or to energy changes. So the thing we did yesterday with the fire, that is called combustion. So what we did was we had methane gas and we exposed it to fire, and when we exposed it to fire, it turned the methane into carbon dioxide and water. So that is a chemical property, the ability for it to be flammable or combust. Oxidation, the ability for it to, when it's exposed to oxygen and water, to oxidize. That is a chemical property. And recombination is something we won't talk about here, so just leave that out of there.
Yeah, that's not good.
Okay, so chemical properties relate to a substance's ability to undergo changes that transform it into different substances. So it's transformed into something new. So charcoal, burning in air, is that a chemical property? Yes. What about if iron rusting? Iron rusting is a chemical property. And silver tarnishing is a chemical property. So it undergoes, it combines with sulfur from like the air and stuff, and it starts to become dull. Silver starts to become really dull. And then what you can do is you can use a special compound and it makes it shine again.
Just don't let off the shit. Still.
So any questions about chemical versus physical properties? You must be able to look at these things and determine if it's a chemical or a physical property. So what I want you to do, now we're going to talk about changes. I want you to take a moment and think about the difference between a physical change and a chemical change.
Okay.
And I want you to write down, if you had to go home and tell your mom and dad, tell them how you would describe in the world of chemistry what a physical change is and what a chemical change is. So write down how you would describe these 2 words to your parents and be prepared to share out. I'm going to give you a minute to write that down. Okay. Does anybody want to share what you have written before I call on a desk number? Anybody? No? Okay. So, my niece, it's her birthday today. And she is turned 18. So, lucky number 18, Marianne.
It was like a little niece. Call somebody a Okay, why didn't get chemical, I just got physical. So I said anything that can be looked at or measured without changing it into something new.
Okay, anything that can be looked at or measured without changing it into something new. All right, what would we say about chemical change? My nephew is going to be turning 15 in a couple of days. So what do we have for chemical change? You didn't write anything for chemical change? No. Okay. What do you have, Hannah?
Chemical change applies to its molecular composition, oxidation, temperature, or combusting.
Okay. If you undergo a chemical change, what happens in the chemistry world?
Something bonds to it or something unbonds.
So we get a chemical reaction. We may have bonds either broken or bonds that are
So like a cake, a
made.
liquid turns into a solid when it heats up.
Okay. So thinking of chemical versus physical change, would ice becoming liquid, water, be chemical change or a physical change?
Physical.
A physical change. What about if you take salt and you dissolve it in that water? Is that a chemical or a physical change?
Physical.
It's a physical change. Okay. A chemical change, if we take iron and let it set out, or what happened to what is the Statue of Liberty made out of? Copper. And copper is a nice, like, brownish, shiny brown color, orange. But what color is the Statue of Liberty? Green. It oxidized over time. And oxidation and when it oxidized over time, it underwent a chemical change.
So it was like brown?
It's like a copper. Mm-hmm.
So it was like originally brown?
Mm-hmm.
No way.
Mm-hmm.
They made it out of green.
No.
Are they painted it or something?
So what you're going to do is the following. You are going to go to the back stations. And there are some cards back here labeled A through I. And you see there's the before, and then there's an after. So there's circles that are before and circles that happened after. So what you need to do is look at what is going on and determine the following. Tell me, you have to describe the chemical or the change. What's going on? Solid became liquid, whatever. Tell me what type of change is it, chemical versus physical, and then be able to defend your decision. No new substances were made, no elements rearranged. Okay? So you need to tell me, describe what's going on and the type of change, and then defend it. What I'm going to do is I'm going to come around to each station and I am going to assign you a letter. And you have to come up with a clever statement. So, what is your claim? My claim is that this is a physical change. The evidence, no elements or compounds were made or rearranged, and your reasoning. Okay? So, you have one really where you just have to kind of go around and say, is it chemical or physical change? And then so you have to do that for A through I, and then the one that you have to make a clever statement for, the one I tell you to make a clever statement for. Are there any questions? So we're going to do this until I'm going to give you guys 15 minutes, and then we're going to share out. All right, get going.